Okay, so last day we looked at section 2.1 and we ended with finding the exact trig ratios, and we also noticed that we were finding standard position, but we were also finding reference angles. Standard position tells us exactly where the angle is. The reference angle is what we use to help find the sine, cosine, the tangent, and that's exactly what we're going to do today. Okay, so first of all, this refers, and I forgot to put this in the notes, can you turn to, sorry, it's in your textbook. Just grab the original here. I lost the page number. Textbook page 91, and it's example 1 on that page. So can you just turn to your textbook for that? I forgot to make note that that's where I got that from. Page 91. Because I don't think I wrote the example down. So there's a question there. It says the cosine of, oh sorry, that's example 3, 90. It's actually page 91. Yeah, we're good. Page 91. Okay. So there's a standard position angle. That's theta. That's this theta. Okay. Standard position, and the terminal arm, that's the arm where it ends, passes through the point -815. Now we know that if we're going to graph the point -815, we have to go -8 in the x direction, in the negative x direction, right? And then +15 in the y direction. And that's where it would be. Does everybody agree? It passes through there. So you have to be good at plotting points. If you can't really remember how to plot a point, or it's something you have to think about, I have a quick little puzzle that would take maybe 2 minutes, and it'll get you going at plotting points again. Okay, so make sure you ask if you need that puzzle. So I'm going to graph this out. I actually didn't show the process of graphing it. So the first thing I would do is kind of approximately plot the point. So I didn't count or anything like that. I just got it there, and I'm doing my terminal arm there, and that's my theta. So that's what I've drawn down below there, okay? Now I'm going to drop this down, and I'm going to use the reference angle to make my right angle triangle. So that's what I did here. I made this right angle triangle there. The opposite side of the reference angle, so that's here, the opposite side is 15. The adjacent is -8. And then the r is our hypotenuse, and there's a reason I call it r, and I hope to show you that later today why we call it r. It's actually r for radius, but it's the hypotenuse. And I can figure out what the hypotenuse is by doing Pythagoras' theorem, so that's what I do here. And I get that the radius is square root 298. And by the way, the radius is always going to be positive. You don't have to worry about it being negative. It's only the y and the x, or the adjacent and the opposite, that are going to have negative and positive values. So the radius or hypotenuse is always positive, okay? And now I can say what the sine is. It's the y value over the radius, because the y value is my opposite value there, right? So the opposite, that was the opposite over the hypotenuse. Okay, so 15 over square root 298. The cosine was -8 over root 298, and then the tangent is opposite over adjacent, which notices the y value over the x value, okay? By the way, tangent is the same as a slope, rise over run. That's interesting with things that come up later on, okay? Okay, so that's how you would find the sine, cosine, and tangent if all you were given was a point that terminal arm goes through. If you're given a point, it's actually telling you your opposite and your adjacent, okay? Okay, so now flip over to your next page. Now this is not in the text. Oh, yeah, I just want to point out here, notice in that example up above, the cosine and tangent are negative, okay? Because, we're going to get more into this later, but it was because the adjacent was negative. We're going to do lots of that today. Okay, So this one says determine the tangent of 210, and I'm going to just get you to put the word exact. Determine the exact value of the tangent of 210. So as soon as you see that word exact, it means we're going to be doing a special angle, 30, 60, 90, or 45, 45, 90. So that exact is really important, okay? We're not just going to punch this into our calculators. You could just go tangent 210 and you'll get some decimal answer, but we're going to get the exact answer, not something that had to be rounded. Okay, so first thing I want to do, and what I've done is I've kind of modeled one sketch to the next of what's going on. So the first thing I'm going to do is I'm going to draw where 210 is. So this is the standard position, right, of 210. We know it's more than 180. So remember from our reference angle work, everything always has to do with 180 and 360. So we know it's more than 180. So it's about in that quadrant. I don't know how much, okay? Now determine the reference angle. So we're going to make a right angle up to the floor. We're going to make it rather a line up to the floor. And because this is the reference angle, not in here, okay, I'm going to erase that because it's not that part in the vertical, okay? So it's not in that area there, okay? It's in this area here. There's our reference angle right there, okay? Okay, so then I drop this up, and if that's 30 degrees, I've got a 36. Oh, how did I find it's 30 degrees? Well, remember this was 210 all the way around, and it's 180 to here, so what's the difference? So I got the difference between them. You should be good at that after doing last night's homework. You should have practiced finding the reference angles, okay? Okay, so we got that that's 30 degrees. Next step is we're going to identify where the 1, 2, and the root 3 is. Remember the 1 is opposite the 30, okay, opposite the 30. And the 2 is the hypotenuse, and the root 3 is the third side. But the root 3 is negative because this point is negative root 3, comma, negative 1. It's in the negative quadrant, okay? So that's where people are going to lose marks. They forget to put the negative signs, okay? Does everybody understand that? Like if I was to plot the coordinate point negative 3, negative 2, I would go back 3 and down 2, right? Both parts are negative in plotting points. So if you're not strong at plotting points, you need to do that other worksheet first, okay? Okay, so I've got where they are. And now I can take the sine, the cosine, or the tangent because I've got all three sides there, okay? I was supposed to do the tangent, which is opposite over adjacent. So there they are. They're both negative, which means my answer is positive, okay? You don't even have your notes out. Not, huh? You don't have them here. Okay. Okay, now we're going to do the supplementary worksheet. This worksheet is on a package, and I do not want you to do the rest of the package today. We might get to it next day. It's extra practice on things, okay? Just hang on, I'm just going to pause this. Just don't let me start again. Okay. It's not in the back? What, someone ripped them all off or something?
I don't know,
Hopefully I'm recording, not hard to tell. All right, here we go. All right, so first of all, don't draw this. Just watch up here for a moment, okay? You're not going to draw this because it's just going to muck up your drawings, okay? I just want to remind you that in standard position, that would be theta 1. This would be theta 2. This would be theta 3, right? And then all the way around, but not quite to 360 degrees, would be theta 4. So I don't need you to draw that on here. You don't need to draw that. I just wanted to make sure we understood that this drawing is more looking at the reference angles, not the standard positions, okay? So I'm going to erase those now so that it's So those could have been on there, and later on we're actually going to draw them because we have to figure out what they are. Okay, but right now we're just going to be talking. We're going to use the reference angles. So each of these are reference angles, or theta r, as sometimes the book refers to them. And notice the reference angles are all the same. They're all the same because they're opposites. Their triangles are all congruent. They all have an opposite side of 3, an adjacent side of 4, and a hypotenuse of 5. The only difference is these say -4 instead of +4. Okay? But all the triangles have the same proportion. Therefore, they have the same angle. Okay, so what we are going to do is practice finding the sine, cosine, and tangent of each of those angles. So first, the angles that are in quadrant 1. This should be very easy. What's the sine of theta 1? Sine means what? Hopefully you know what sine means by now. What goes on top for sine? Opposite over hypotenuse? No. So we need to know these. This you should know by now. You should have it memorized. So I think I'm just starting to discover a few people that do not yet have that memorized. After doing Math 10, you should have had that memorized. Just by sheer doing so many questions, you keep repeating either a sine, a cosine, or a tangent, and you start just learning it. It just starts learning. But if that didn't, maybe you didn't do the homework last year, or maybe you just forgot it from then, you need to put them on cue cards and you need to memorize them, because we're going to do way more difficult questions. And if you're just sitting there trying to figure out what a sine is, you don't even know that sine is opposite over hypotenuse, how can you do the much harder question with this? Okay, so it's very important that you're not struggling with what is sine. If I say sine, you should just automatically know opposite over hypotenuse. Okay, is that clear? Can you all take that responsibility to make sure you know what those are? Okay, so sine is opposite. That's this one over here, 3 over, sorry, it's not writing, over the hypotenuse, which is 5. So 3 over 5 is the sine. What's the cosine? Cos is adjacent over hypotenuse. The adjacent is 4 over 5. And tangent is opposite over adjacent, 3 over 4. Okay, is everybody good with that? Now, when we get into the second quadrant, we have to watch for negative sign. The sine is still positive 3 over 5, right? But the cosine now is negative 4 over 5. And the tangent is 3 over negative 4, but a better way of writing that is negative 3 over 4, okay? One negative sign means the fraction is negative. The decimal of that fraction is 0.75, so it's negative 0.75. It's not incorrect if you write this, though. I don't really care, okay? It's just easier for your calculations. Okay, let's do the third quadrant and the fourth quadrant. Okay, the third quadrant, the sign this time is negative 3 over 5. By the way, notice that hypotenuse is always positive 5, right? So it's negative 3 over 5. The cosine is still negative 4 over 5. And the tangent is negative 3 over negative 4. And you should never, ever write a fraction with two negatives. That's positive 3 over 4. So don't ever answer with that. I'll actually mark it wrong. Okay, so make sure you know that two negatives, when you divide two negatives, it makes it positive. So the tangent's actually positive there. Strange. And then the sign over in the other one is negative 3 over 5 for the sine. The cosine is positive 4 over 5. Let's just take a look at that. See, the adjacent is positive. And the tangent is negative 3 over 4, and that's negative. Okay. So I've asked a question, in which quadrants is the sign negative, and why? What makes it negative? In which quadrants is the sign? 3 and 4, because, why? because the y values are negative. Okay, the opposites are y values and they are negative. So it's in quadrant 3 and 4 because the y values are negative there. So that's what makes sign negative. Now I'm going to fit something else on this page, which I should have given room for, and I'm going to do it next time. I'm going to ask, where is the sign positive? So you're going to draw a little diagram like that, and it's positive here and here. Okay. If I actually want to, if you can draw the standard position, that's good too. Okay. And where is the sign negative? It's here and here. Okay. So all the way around to there and all the way around to there. Okay. So the sign's positive up here because the y values are positive, negative down there because the y values are negative there. Where's the cosine positive? Where is the cosine positive? Which quadrants? 1 and 4. Okay, 1 and 4, because the adjacent, sorry, that didn't work out too good, but the adjacent is positive there. No. Okay, so cosine's positive there, and it's negative over here. You would have an angle going like that, and then an angle going like that. How about the tangent? Where's the tangent positive? Definitely in the first quadrant, because everything's positive there. And then 3, where you had that negative, negative. And the last one is the opposite of that, right there. That's where the tangent is negative. Okay? After you've done some questions, if you keep drawing this out, remember, when in doubt, draw it out. As you do a lot of questions, you'll just start being familiar with where your tangent's negative. Right away, you're going to think of where it is, okay? But if you want to, you can just kind of memorize that. But there's a reason for these, right? The cosine is positive because the adjacent here is positive, okay? The cosine's negative over here. Negative here because the adjacent is negative. The sine is positive here, but negative down here, right? Okay, but it's the adjacent that tells us the cosine. Okay, on to the back of the sheet. Okay, so we're going to get this kind of question. If the tangent is 0.379, in other words, if the tangent is positive, then I'm going to draw it in the first quadrant, like that, and in the third quadrant there. And I don't really know how steep it is. I'm just guessing. I could have drawn it like really steep. It doesn't really matter. You're just sketching where you think it is, okay? So it doesn't matter how steep it is. And then always draw your standard position in there, okay? And then those little black things are my reference angles. I'm going to refer to those angles to figure things out. It's actually the reference angle I'm going to find first, okay? So that's the kind of picture I want you to start drawing. Cosine, if the cosine is negative, okay, this is the type of question you might get. Then I'm going to first draw it over here and down there in quadrant 2 and quadrant 3, and then I'll do my standard position, but I also identify my reference angles. I'll just draw R for reference angles in here. Okay, those are my reference angles, right? And I'm always drawing a line from the terminal arm up to the x-axis so that I can use my reference angle. I'm actually only going to do that when I'm doing special triangles, okay? These are not special. In this case, I'm just going to go shift cos. But I'm going to talk about how to do that later. I'm going to go back to our trig notes, okay? I'm going to get to the rest of this later on. I just want to go, well, actually, maybe we should just do that. Let's practice that. Let's get the locations of these situations. We're always going to be doing angles between 0 and 360 degrees. You guys remember theta is our angle, okay? So I'm always going to go between 0 and 360 degrees. So my sine, which is the ratio, not the angle itself, my sine is negative. That's fine. Where would the sine be negative? Which angles are going to give us a negative sign. Where would they be? Draw them out, and then let's see if you've got what I have. So I want you to fill in where you think the sign is negative. You might have to flip your page back and see where the sign is negative, or maybe you just remember that negative is the y values, or the opposite values. Okay, is that what you have in quadrant 3 and 4? And then we're going to, I'm going to be teaching you in the notes how to actually solve for it, okay? Okay, and in B, where's the cosine? Positive. That's a positive value. So where's the cosine positive? Let's draw a picture of that. Cosine is the adjacent, so we want to know when is the x positive, and it's positive over here. So that'll be here and here. So that's one of your angles, and our other one is almost 360 degrees. How are we doing? Getting the idea? Okay, tangent negative. Do you remember where the tangent is negative? Remember, all angles, all sine, cosine, and tangent are positive in the first quadrant. So the tangent for sure is over here. And where's that other one? Straight ahead, yeah, on 4, okay? And this is my standard position, and this is my other standard position. Now, I want you to just do a dark angle where the reference angle would be. That's something a lot of people will end up getting wrong. So let's make sure we know where the reference angle is going to be. So up here, it's going to be in there. And down here, it's going to be here, right? It's always to the x-axis, that reference angle. We good? Okay, back to our trig notes. I'm going to get to the quadrantal angles in just a moment. I want to solve for an angle if I give you the ratios. So I'm going to go back to the quadrantal ones. I've got this fantastic interactive website that'll help you explore how to do that. So I'll get to that in just a moment. That website, by the way, is on my website. If you go to PreCalc 11 and then to the trig section, you'll see the interactive website. Okay, so it's linked to my website. Okay, so let's say I'm asked to solve for theta, given that the cos theta is negative root 3 over 2. Right now, I got big warning flags going up in my head. I got a root 3. That reminds me of a special triangle. Which special triangle? 30, 60, 90 or 45, 45, 90? 30, 60, 90. So it's probably either 30 degrees or 60 degrees. You could take a guess at this, but I'll be expecting you to show me your work, okay? Okay, so notice it's an exact value, so it's a special triangle. So the first thing we're going to do is sketch a picture where the cosine is negative. Okay, so that's the first thing I did there. Don't worry about your angle size. We don't really know how big the angle is. Second thing we're going to do is fill in, actually find the reference angle and then fill in the sides. Okay, so this is our reference angles. And so I knew that the, hang on, let me just relearn, what was that question? Cos of theta was, is it root 3 over 2? Negative root 3 over 2, is that what it was? Okay, yeah, there it is, okay. So that means the adjacent is negative root 3. That's why I put that there. The adjacent, cosine is adjacent over hypotenuse. You can see why it's so important to know what a cosine is. If you're having to go look at your SOHCAHTOA before you can even start this question, you'll forget what you're doing by the time you get back. So it's very important you just know what cosine is right off the bat, okay? Okay, so I placed the root 3 there. My opposites, though, the one that's right, I just got to get a pointer. This opposite is positive because it's going up, and this opposite is negative because it's going down, okay? Because it's -1 down. It's the y value. That's just how we plot points, okay? Okay, now that doesn't matter. These do not matter. We're not even going to refer to them. We're going to use that √3/2, okay? So now we can determine what we find the cosine. We've got our 1, 2, and √3 in the right place. We've got to figure out if they're positive or negative. And now we're going to use that reference angle to determine the standard position. So if this is a 1, or if this is a -√3, what's R? It's between 30 and 60. What's R going to be? Which is the one opposite the 1? 30. Okay, so again, that's something else you want to have already memorized. So the R was 30 because it's opposite the -1, so it must be 30 degrees, okay? So now we're going to figure out what our θ1 and θ2 are, and I'm just going to draw where θ1 is on here. So this is θ1, even though it's in quadrant 2, I'm just going to call it the first theta and the second theta, okay? That's why I call them θ1, θ2. The first angle is 180 degrees minus that 30 degrees, 150. And the second one is 180 degrees plus that 30 degrees, okay? So those two angles, 150 degrees and 210 degrees, will give the same cosine. You can punch them in your calculator if you don't believe me, because it'll give you the same decimal answer on your calculator, okay? All right, so that's how we do that. And then I gave another example without the special angle. So we're covering a lot. You're going to go home and try to do half an hour to an hour of homework. You're not going to get it all done. You're doing 2.1 and 2.2. And then when you come back next day, we're just going to work on more, okay? Because this skill, there's about 10 things to learn, but I don't know which of the 10 things to teach you first because they are all interconnected, okay? So I'm just throwing all this stuff at you, and then we're just going to really work through this stuff, and we'll get to the hard questions when you come back next day, okay? Okay, so if I'm going to do the cosine is some decimal, this time it's not an exact situation. I'm going to be using my calculator, okay? So the first thing we do is draw where the cosine is negative, so same idea there. Sorry, I should use cosine. I should have used a different trig ratio, but anyway, I used cosine. I do later on. I gave you 2 more examples down here. Okay, so anyway, I draw where it is. Now, I want you to use your calculator to find the reference angle, and you do that by using the positive number, not this negative one, but the positive, because what that'll do is find this right here, and that's what the reference angle will be also. So if it was in quadrant 1, I would get what the reference angle is, okay? So go shift cos. Do you guys remember this here? That's shift cos. My pen's not writing. Okay, shift cos of 0.67. Everybody do that right now on their calculator and see that you get the same thing. So make sure you do shift cos. Notice I'm using the positive 0.6753 because all I want to know is what the reference angle is. I'm not going to actually get the standard position yet. Does everybody get 47.5? Shift cos, second function cos. Okay. And now I'd like everybody to do the shift cos of negative. We're going to solve that one there. Do the shift cos of negative. Let's see what you get. So if you do this one on the calculator, what do you get? 132? About 132 point some. That's your first angle. It actually gives you your first angle. Okay? If I use this, I can get my first angle by doing 180 minus the reference angle. But then I can get the second angle by doing 180 plus the reference angle. So if I get the reference angle, I can find both angles, no problem. okay? If I do the shift cos on the original problem, I'm going to get the first angle, but it's actually hard to figure. You'll have to get the reference angle from there in order to figure out what the other angle is. Everything is very symmetrical though here, okay? I'm just going to erase this. Okay, so if this is 153, then so is this, okay? Okay, that's all I can say for now. And